Hello dear students, in this video we are going to learn a new topic called rational number, which is the first lesson of your class 8. But before we learn about the rational number and before I introduce you the concept of rational number, let's watch a video to understand how our number system has developed. Already in your 7th standard and 6th standard you have learned about so many types of number sets, right? By watching this video, let us recall the types of number set and how that number systems has developed. Okay, so watch the video.
Rational numbers. This is the story of numbers, types of numbers, a lot of examples and their uses. So let's jump right in. A long time ago, man used his fingers or markings on bones for counting, and later devised various symbols or figures for each number. While in those times, man normally counted the animals he killed and ate. Several thousand years later, man is still counting, although mostly money. Counting comes naturally to us as something that goes 1, 2, 3, 4 and so on. Hence, such numbers are grouped as natural numbers with the symbol n. Well, you may be rich one day, but there are days when you are flat broke with no money left. So when it comes to describing the notion of nothing, a number 0 was discovered. When we add the number 0 to the set of natural numbers, we get what is called as the whole numbers, symbol W. In most circumstances, these are the numbers we deal with. Nothing more, nothing less. Except of course, certain situations prove this to be not true. For example, when you have to measure the depth of a ship below sea level. When the temperature drops to sub-zero under very chilly conditions. And of course, when you owe money to the bank. In all such cases, the numbers are called as negative numbers, which when clubbed together with the whole numbers, form a new group called integers, strangely denoted by the letter Z. The term integer, as a matter of fact, is derived from Latin word that means whole, intact, or entire. So far so good. However, there are situations when you are required to deal with parts of a whole, or fractions as they are called. For example, parts of a pizza, measuring height more accurately, in this case 1.5 meters. Calculating the fraction of a difference in time in a very close race. Specific measures of ingredients in a cake recipe, yum, and so on. So any and every number that you can practically think of in the real world, which can be denoted as a fraction or in a decimal form, constitute what is called as real numbers, expressed as the symbol R. Now take any integer, say -4. This number can be denoted as a fraction, namely -4 upon 1. So all integers are real numbers too, as obviously are the whole numbers and the natural numbers as well. Here are some examples of real numbers on the number line. We have 3 upon 2, which is 1.5, -1 upon 3, which is 0.3333. Just keep repeating the decimal digits. The number 6, 18 by 5, etc., etc. Now most of the real decimal numbers can be expressed in form of a ratio. What I mean by this is that the number can be written as a ratio of two integers. Of course, the denominator cannot be 0. For example, 0.4 can be written as the ratio 2 upon 5. -0.375 is -3 upon 8. Also, 2.33, where the decimal 3 keeps repeating forever, can be expressed as 7 upon 3. So the numbers that can be expressed as ratio of integers, where the decimals terminate or repeat, are called rational numbers.
Okay, so you all watched video. So that way has given you the introduction about the number system and how the number system developed. So in this slide you are watching a brief summary of the video. Whatever you saw in the video, that brief summary you are watching in this one. So in our number system, so inside this, the natural number set. Natural number set is a basic number set which we call as counting numbers, starting from 1, which we use in our daily life, right? If to that natural number set, if you include 0, it will become a set of whole numbers. Counting numbers with 0 are called as whole numbers. Now, to this whole number set, if we add the negative numbers also, then the set will become a set of integers. Integer means it is having negative number also, it is having 0 also, and it is having the positive number from 1 also. Now, all these natural numbers, whole numbers, integers combine together to form a set of rational numbers. So, rational number will have whole number also, natural number also, integers also. So, all these numbers are combined to form a set of rational numbers, and there is one more set which is an irrational numbers, and totally all this will be considered as a real numbers. So, this is our number system. Okay. Now, we understood what is the number system and what type of number sets are there in our number system, right? Now, let us come to a topic. Let us define a rational numbers. So, rational number means it is a number which is of the form p by q. P by q means it is in the form of a fraction where p and q are integers. Integers means they may be a negative numbers, they may be a positive numbers, or it may be a number 0 also. But the condition is q should not be equal to 0. Means denominator of p by q should not be equal to 0. Such type of numbers are called as rational numbers. That is how we are going to define the rational number. Let us repeat one more time with me. And numbers of the form p by q, where p and q are integers and q not equal to 0 are called as rational numbers. Usually we denote the rational numbers with the letter q. Q is used to represent the set of rational numbers. Let us see some examples of for rational numbers. I have taken 4 examples. Like this, you can write so many examples for the rational numbers. So, 5.3, 1 by 4, minus 7.2, 7 by 10. Their examples are in the fraction form also and decimal form also. Because decimals also you can write in the fraction form. So, we consider decimals also as a rational number, etc. So, like this you can list so many examples for the rational number, which include negative number, positive numbers. You can write it in the decimal form also, you can write it in the fraction form also. But you should keep one thing in your mind. If you are writing it in a fraction form, denominator you should not take as 0. If you take denominator as 0, will not consider that as an rational number. Okay. So, that like that list 5 more examples for the rational number. List your own examples. Okay. Okay. Next, let us move on to the properties of the rational number. What properties are there for the rational number? That thing we are going to learn now. So, first property is closure property of a rational number. These properties will apply for the rational number. Closure property means you are taking two natural numbers, for example 1 and 2. You will add those two natural numbers. 1 plus 2 is equal to 3. 1 and 2 are natural numbers. After adding you got 3. Now 3 is also a natural number. 3 is also natural number, right? So whenever you are adding two natural numbers and your answer is again a natural number, then we say that the closure property is applied for that natural number set under addition. In the same way, for rational number also we can explain like this itself. So, you are taking any two rational numbers, You are adding those two rational numbers. After addition, your answer is again a rational number, which is in the fraction form. So you will say that the closure property is satisfied. So here, for the rational number, when you add, that time also you will get a rational number. When you subtract two rational number, that time also you will get a rational number. And when we multiply two rational number, there also we are going to get the rational number. So we can say that rational numbers are closed under addition, subtraction and also multiplication. So that is the first property of the rational number. Hope you understood. So there I gave three examples, one for addition, one for subtraction and one for multiplication. 7 by 6 plus 2 by 5 is equal to 47 by 30. After adding two rational number, we got again a rational number. Next, second example, we subtracted 2, answer is again rational number. In the third example, we multiplied two rational numbers and our answer is again a rational number. So that is the first property of the rational number. Let us move on to the second property, commutative property of the rational numbers. So this is also the same, but here it is little bit different from the closure property. For commutative property, like this we can explain. Okay, here again I will take two simple numbers, 1 plus 2. Same example I will consider. 1 plus 2 is equal to 3. Then how much is 2 plus 1? Yes, right. 2 plus 1 is also 3. Right. So in the first, we have taken 1 as a first term, 2 as a second term. And later on, we changed 2 as a first term and 1 as the second term. Means same numbers we have taken, but we changed the places of the number. First we took 1 plus 2, next we took 2 plus 1, right? Same numbers we are taking, but we are changing the places of the number. But there is no change in the answer. 1 plus 2 is also 3, 2 plus 1 is also 3, isn't it? So that is called an commutative property. After changing the place of the numbers, still you get the same answer, then we say that the commutative property is satisfied. So for commutative property of rational number, it is satisfied for addition also and it is satisfied for the multiplication also. When you multiply two rational numbers by changing their places, you are going to get the same answer. And when you add two rational numbers by changing their places, then also you are going to get the same answer, which is a rational number. So here you are watching, you can see the general forms of commutative law for addition and commutative law of multiplication. General form of commutative law of addition, a plus b is equal to b plus a. For multiplication, a into b is equal to b into a. Right? Okay. Next, subtraction is not commutative. Means when we subtract two rational numbers, we will not get the same answer. It is not commutative. When you do the subtraction by changing the places of the rational number, you will get different answers. So subtraction is not satisfied the commutative property. So there I have taken the examples. You can see them. 1 by 3 minus 2 by 3 is equal to minus 1 by 3. But in the next example, I am changing the places of the rational number. 2 by 3 minus 1 by 3 is equal to 1 by 3. In the first case, it is minus 1 by 3. But in the second case, it is 1 by 3. So when you changed the place, you got different answers. So we say that for subtraction is not commutative for the rational numbers. Next, division is also not commutative. That is, a by b is not equal to b by a. So when you change the places and divide, there also you are going to get the different answer. Example, 1 by 2 divided by 4 by 9 is equal to 9 by 8. Same two rational numbers we took, but we changed the places. 4 by 9 divided by 1 by 2, but this time we got 8 by 9 as the answer. So division is also not commutative for the rational numbers. Next, move on to the next property, associative property of rational numbers. So in the associative property, we consider three rational numbers. Here we change group of the numbers. Means we keep the numbers in the same places, but we group them differently. For example, as you can see, x, y and z are rational. Then for addition, x plus y plus z is equal to x plus y plus z itself. So there is no change in the places of x, y and z. Here also you have x, y, z. There also you have x, y, z. But in the LHS you grouped x plus z. In RHS we are grouping x plus y. Sorry, here we group y plus z. Here we are grouping x plus z. Multiplication also same. Order is same. X, y, z, x, y, z. But grouping is different. Here y, z in one group and x, y in one group. So when you apply this associative property to the rational number, after changing the group also, you are going to get the same answer for addition and multiplication. But this associative property is not satisfied for subtraction and division. So you can take some examples and you can check it. Okay, so that's thing you have to write down in your notebook. You should take the examples. You should apply the commutative property for that, for addition, subtraction, multiplication and division. And you take three rational number, you apply the associative property, do it for addition, subtraction, multiplication and division, and check whether it is applicable for subtraction and division or not. Okay. Okay, next let us move on to the next, additive and multiplicative identity. So normally for all the numbers, 0 is an additive identity and 1 is an multiplicative identity. So that is same for rational number also. So additive identity means whenever we add 0 to any rational number, we will get the same number itself as the answer. So that thing happens in the case of whole number also, integers also, and the natural number also. So we can say that 0 is an additive identity for all the types of the numbers. Whenever we add 0 to any number, we will get the number itself again. And 1 is a multiplicative identity, means whenever we multiply 1 to any number, we are going to get the same number again as the answer. So same thing happens for all the types of the number. So we have to remember the additive identity and the multiplicative identity. Okay, next is additive inverse and multiplicative inverse. So that is very important concept. Additive for a rational number x by y, the additive inverse is minus x by y, and y by x is the multiplicative inverse. Whatever rational number you take, if you add a sign, if you change the sign, it will become additive inverse. If you take its reciprocal, it will become a multiplicative inverse. Reciprocal means if you write in the reverse order, if you take numerator in the denominator and denominator in the numerator, that will become the multiplicative inverse of the number. I have taken two examples. You can see that additive inverse of 1 by 2 is minus 1 by 2. So if you add the opposite sign of the fraction, it will become its additive inverse. Multiplicative inverse of minus 5 by 4 is minus 4 by 5. In the case of multiplicative inverse, you will not change the sign. Sign will remains the same, but the denominator of the fractions comes to the numerator and numerator of the fraction goes to the denominator. That is the difference between additive inverse and multiplicative inverse. One more time I am repeating that additive inverse means whatever is given, write the same thing with opposite sign. 1 by 2 is given, we are writing it as minus 1 by 2 as the additive inverse. Okay. 2 by 3 if you have means you should write as minus 3 by 2. 2 by 3. If you have minus 4 by 5 means its additive inverse will be 4 by 5. Fraction will not be changed, just you have to change the sign of that. So that will become the additive inverse of that rational number. Multiplicative inverse means you should keep the sign as it is. There will be no change in the sign, but you have to write your fraction in a reverse order. Reverse order means whatever you have in the numerator, you should shift it to the denominator, and whatever you have in the denominator, you should shift it to the numerator. Like that, you have to write the multiplicative inverse of your rational numbers. Okay, now let us take your homework questions. Write down the first question. List and write the additive inverse of any 5 rational numbers. You take any 5 rational numbers of your wish and you write the additive inverse of all that rational numbers. Second one is list any 5 rational numbers and write their multiplicative inverses. Take rational numbers of your own wish. If you have a textbook, you can select the rational numbers from the textbook also, or you can write your own rational number and write their multiplicative inverses. Next, question number 3 is consider any 2 rational numbers and check the closure and commutative property for them. So whatever I said when I explained the properties, you take the rational numbers, any 2 rational numbers, you apply the closure property for addition, subtraction, multiplication and division. Apply the commutative property for addition, multiplication, subtraction and division, and check whether it is closed under addition or commutative under addition. You have to check it. Next, fourth question is consider any 3 rational numbers and check the associative property. Consider any 3 and check for associative property. In the associative property also you have to do it for all the 4 operations: addition, subtraction, multiplication and division. So this is your today's class and this is your today's homework. Hope you understood whatever I explained in the video. If not, watch the video one more time, okay, and do your homework. Thank you.